Okay, so next is sine law. So sine law is, we're now looking at triangles that are not right angle triangles, okay? Right here is the best outline for sine law, okay? You have actually already learned sine law, so this is really just a review. Sine law, what you need for sine law, you must have two side lengths and one corresponding angle. So that means the side length and one angle has to be across from that side length. Or you must have two angles and a corresponding side length, okay? You need to have 3 bits of information at a minimum. So for SOHCAHTOA, this is here they draw, or SOHCAHTOA, sine law, they draw this triangle here and they say this is what they mean. This is a side length, this is a corresponding angle. This is a side length, this is a corresponding angle. And then you set up ratios. You say side length over the sine of that angle is equal to side length over the sine of that angle, okay? So in a question like this, what you do is use the sine law to determine the measure of angle theta. Okay, well, first things first, I know I have this side length and this angle. Everyone agree with that? And then I'm given this side length, and luckily in this question, I need that angle. Okay? So what happens is, I'm going to say, okay, my side length of 112 over my sine of 104 is equal to my side length of 72 over my sine of theta. I don't know what it is. Okay? Again, you're going to use Zorro, but the only difference here is your unknown has sine involved in it too. Okay? So sine of theta is going to be equal to, again, please always put the number out front, because if you put it after, like we're used to, you'll end up multiplying 104 by 72 first, and that's wrong, okay? So if you always put the number out front of sine, it'll work. So now I'm going to have, okay, 72 times sine 104 equals, then I'm going to divide by 112, and I'm going to get a decimal. So sine of theta is equal to 0.6236761, and so on. So what do I do when I need a decimal to be an angle? I hit second function, sine, and I retype the decimal, or I use my answer button. So I actually, once I get my angle, I have 39 degrees rounded. So angle theta is 39 degrees, and that was rounded. How's that? Does anyone vaguely remember this from before? If you've been out of school for a while, this is not something you just magically keep in your head, okay? So, but it will come back as you practice it. Sine law is the easiest of the two. Cosine law has a little bit more involved in it. Okay? So again, you just set up the ratios based on the information you have, and then you do your Zorro method. Okay, everyone has this written down? Yes, Helen? Okay, thanks. Sorry. I can't read minds. Okay. Oh, they're tricking us up by making us draw a triangle. Every single triangle I draw always looks the same. I don't know why. I always try to mix it up, but they always look the same. As long as it represents approximately the diagram, you're good. The first thing I always start with is I always look at one angle. If I have a really big angle, then I'm going to make it look really big. Okay, so in this case, I know I have an angle. Oh, and I didn't even do it. Wasn't even that big. I know I have an angle of 132 degrees. Everyone agree with that? So what I do is I just sort of draw that angle, and then I fill in the rest of the triangle based on that information. Pardon? I told you I'm not great at it, okay? So we know that this is angle D, right? So D, E, and F. We just go around in a circle. They say that we have angle D, but we also know that side length D is 7.9, so I'm going to fill in 7.9 centimeters. And I know side length F, which is across from angle F, is 12.5 centimeters. Hopefully they're asking us for angle F, which in this case they are. They want to know what theta is. You can pull that open a little now if you want. You can stop blowing because the sun's not reflecting off the cards anymore. Okay, so based on my triangle, what I'm going to make sure I have is I'm going to make sure I have side lengths and corresponding angles, side lengths and corresponding angles, which I do. So determine the measure of f to the nearest degree. So what I need to do is D is 7.9 over sine of 132. And that is equal to side length 12.5, which is my f, over sine of theta, because I do not know my degree. Now, in a second, we're going to see a question where we know all of our angles, but we don't know our side lengths. The same thing works, right? It's just you always create your Zorro based on the unknown. So here I start my Zorro. I'm going to come over here just so I don't have to bend down too much. Sine of theta is equal to, remember, I'm always going to put that number first because otherwise my calculator wants to multiply them together. So, 12.5 times sine 132 equals, then I'm going to divide it by 17.9 equals, and sine of theta, I'm going to get my decimal of 0.518955, and so on. You do not need to write this decimal part. I'm just reminding you that you have to do, that it does exist. Second function, sine, I use my answer button, and I get 31 degrees. Angle theta equals 31 degrees. Okay. Again, sine law is the easiest of them all. I even think sine law is a little easier than SOHCAHTOA, to be honest, because you don't have to, you don't think so? SOHCAHTOA, you always have to just illustrate which one's which sometimes gets people where this one, it's just there. It's you either have the information or you don't. But to each their own, whatever you're comfortable with. By the test time, hopefully you're comfortable with all of them. Okay? Thanks, Herschel, for responding. Okay, next. Can I go to the next one? That's an unhappy dog. Okay, next. Determine the length of the indicated side to 1 decimal place. So now all of a sudden, determine the length of the indicated side to 1 decimal place. Okay, can I do this? Well, can you do it?
You probably need to find the missing angle first.
Yeah, and how would you?
I can see it in my head.
Okay.
Yeah,
so what you would do is you're going to do this,
yep,
okay? And then what you're saying is you're going to have to find this first,
yes.
Okay? So in order to find this, so this question is going to have an extra step because I don't have enough angles to solve my question. So before I can solve for y, I need to figure out all the angles in my triangle so that I have the angle corresponding to side y. Okay, so in this case, I get 4.1 over sine of 116 equals 1.0 over sine of theta. Okay? I can do my Zorro method. And I'm not, do you need me to show the work for my Zorro, or can I just jump right to the angle?
Show it.
Show it?
Yeah, show it. You don't get it. Show it.
Yeah, I'm trying to get you guys out of here. So I get 40 degrees rounded. 40 degrees rounded. So now I know that this here is 40 degrees. Can I figure out...
Carry on, Columbine. What please, carry on?
Can I figure out alpha? The top angle? What do all my angles in a triangle add to?
180.
So I can go 180 minus 116 minus 40 gives me what?
Therefore,
24 degrees. So now I know this to be 24 degrees. So now I have, okay, I have 24 in y, and I'm going to use this again because that was given. I'm going to use the one that was given.
that was a big mess.
You done it?
Yeah.
But do you understand where I'm coming from with it? Okay. As long as you're here, then it doesn't matter, right? Okay. So now I'm going to go 1.4 over sine of 116 is equal to, I know it, I'm trying to find y, and it's over sine of 24, which I just found. Do you agree with that?
Mhm.
So the given, and now I've calculated. Now I'm going to do my Zorro, but now my Zorro starts from my y value. So I get y equals 1.4 sine 24 divided by sine 116. And I'll oh my goodness. This is the hardest type you will get of this. Okay? I promise. Okay, so now all I do is on my calculator do the work, okay? So 1.4 times sine 24 equals, then divide it by sine of 116, hit equals. Okay, that makes sense. I'm like, why is it so small? So y is equal to 0.63 centimeters. Is it centimeters in the question? Yeah, centimeters. Which makes sense because the other ones are really small, right? Like one side's only 1 centimeter big. So that looks like it should be the smallest side and it's less than a centimeter. So we're okay. Yes? Other than it's a mess, are we okay with it? It's just a lot of steps of you doing it over and over. Okay. Can I go? Oh, here. Okay, can I go to the next slide? Okay. One more. So we have triangle GHI. One has an angle of H has an angle of 100, I has an angle of 39, and H has a side length of 37. So we're going to draw. So first things first, I know my triangle is just going to be a tiny bit bigger than 90 degrees because this is 100 degrees. Oh, 100 degrees. I'm going to label this as H, G, I. So we know I has an angle of 39 degrees, so I'm going to plug that in, and H has a side length of 37 meters. They want to know what our side length G is. So they actually want to know this, which is not a big deal, because can I calculate angle G? Can I calculate angle G here?
Yeah.
Okay. So angle G is equal to 180 degrees, subtract 100, subtract 39, because they give us everything. So this is an easy one. I don't need to really calculate anything too tricky, because it's already there. So that becomes 41 degrees. Okay? So this would be 41 degrees. So now I have G in 41 degrees, and I can use H, which is 100 degrees and 37. I know my diagrams look messy, but when the triangles are written nicely on a test or something for you, it's very, if you circle them the way I'm doing so you can see which ones grouped together, it really does help for not making mistakes. So 37 over sine 100 is equal to G over sine 41. I start at my G and do my Zorro. I'm going to come up over here so I don't run out of space. So I have 37 sine 41 over sine 100. So 37 times sine 41, then hit equals, divide by sine 100 gives me 25 centimeters, or meters, excuse me. Okay, so we